Hello and welcome back to another video. In today's video we're going to be talking about set theory, and this is going to be a very introductory based video where I go over what set theory is, some examples of set theory, some of the notation behind set theory, and some of the ideas that can help you understand it a little bit more intuitively. So let's begin by asking, what is a set? And well, this has a very broad description. It's the collection of objects or members. And that's all that a set is. It's a certain collection of objects. So for example, it could be all of the presidents of the US. It could be all the Skittles in a bag that you bought from the store. It could be a collection of numbers as well. So let's go ahead and write one of these sets. Let's say we have the set and we use curly brackets to define when we begin the collection of objects for a set. And let's say we have apples and oranges. I'm just going to abbreviate OJ, and maybe some berries as well. Here we just created a set of objects or a collection of objects. And it can be this abstract if you want it to be. It could also be numbers. It could be places. Let's not abbreviate places. But it could be any collection that you want. And it could be any object in any domain of study or interest that you want as well. It doesn't necessarily have to be something that can be represented pictorially or even numerically. So we could have ideas as a collection of objects as well. We could have pictures, so we could have the set of different faces that you can make. Sorry, not a bracket, or not a parenthesis, but a squiggly bracket. And so that's going to be the basis of what a set is. And we use capital letters to define a set. So for example, we can say A is equal to 1, 2, 3. We could say that B is equal to all the stars in the galaxy. And so we've kind of built this very fundamental idea of what a set is and a way of thinking about a set as well. It's just a collection of objects where these collections could be anything that you want, really. Of course, in math, we're going to be more concerned with collections of numbers than anything else. But a set can be a collection of anything. One way of thinking about sets, there we go. One way of thinking about sets is that it's a bucket. So earlier we defined A. So A is equal to the bucket, and I believe we just defined it to be 1, 2, 3. So it's equal to this bucket where the items within this bucket are going to be 1, 2, and 3. And these are all of the items within this bucket. So we can have buckets within buckets, which is why I'm introducing this idea now, so that later on, when we come back, we can kind of understand that it's just items within a bucket. It kind of helps ground your understanding of what a set is. And again, let's say B is equal to the bucket of faces that we can make. That one looks like it's smiling. That should be a flat face. So now we've kind of created this understanding of what sets are. as well as what these objects are. There is one more piece of notation that I want to go over real quick. So we have defined the elements within the set A, and those elements are 1, 2, and 3. If we want another way of saying this without defining the entire set A, then we could use the notation 2 is an element of A, or 3 is an element, 3 is an element of A. And so we use this little e here to represent that 3 is going to belong within this set over here. So smiley face is going to be an element, it's going to be an element within B. And if we have another set here, C, which is going to be the set of 1, 2, 3, as well as smiley face, annoyed face, and sad face, then we could write that smiley face is both an element of C and smiley face is an element of B as well. So sets can have multiple, or elements can belong to multiple sets. And there's two main ways of representing sets. First, we can just list out all the members or elements within a set. And this is what we were doing up here. We were just picking a random set and we were listing the elements out. Or we can state the conditions that are required to be within that set. So for example, we could have D is equal to the set of all people that are president, or that were the president. So here we begin with a broader set. We begin with all the people, and then we narrow it down using some sort of rule or some sort of condition that has to be met. So for example, here we start with people, and then our condition is that they had to have been the president at one point. So we could write this as D is equal to X such that X must meet some criteria. There. So here we have our elements, and then here we have the condition that these elements must fit into. This vertical bar here can be read as such that. So X such that X must be Z. And not all of these elements are going to be met, right, with whatever criteria that we have over here. For example, not every person on the earth has been the president. Only a very select few have. Going back to listing, because this is going to be slightly easier for now, we're going to really hammer this home so that we can get a concrete concept of what sets are. So beginning again with A is equal to 1, 2, 3. We can also write that C or D or whatever set we want to pick, let's say P, is equal to 1, 2, 3, 4, and then we can use these ellipses here to represent that this pattern continues on until we stop it, so 7. So this is the same as saying the set of 1, 2, 3, 4, 5, 6, and 7. And again, we don't necessarily need to stop it because numbers are infinite. So we could say Q is equal to 1, 2, 3, 4, and then we can just keep going on forever. And this right here, P, is going to be an infinite set. Or sorry, this is going to be a finite set. Meaning that this set ends. It has a set number or a finite number or a limited number of elements. Whereas Q has an infinite number of elements. It keeps going on forever and ever. This is also a good time to note that sets don't really care about order or repetition. So for example, if we have M, N, O, and M is equal to 1, 2, 3, N is equal to 3, 2, 1, and O is equal to 1, 2, 3, 2, 2, 1, 2, 3, then these are all going to be the same since they only have 3 unique elements. So here we have 1, 2, 3. Those are the only elements that we care about. Here we have a bunch of repetition, but once we repeat it, it doesn't really matter, we can just get rid of it. And here, again, order does not matter for sets. Does order matter? No, it doesn't. And does repetition matter? No, it doesn't. And we just showed that. And that's going to be it for this video. If you have any questions or comments, please let me know. Hopefully, this was a good introduction for you to start understanding what sets are. They can be a little bit more of an abstract concept, so it takes a little bit to understand them. Thank you so much for watching, and I hope that you have an amazing day.